Let's get started. So let's quickly review what we have been done in the last class, and then quickly, hopefully we finish everything up to the Excel. And then we'll talk about Excel next class, or if possible, we cover some Excel. So, oh, sorry, I think I got the wrong slides. Let me. Wrong slide. So now get it back. So the topic one is related to descriptive statistics, and it is concerning about how to get a much clearer picture of the data by itself. And then we talk about the visual representation is a good one. And the other way to look at it is to numerical one. We look at the mean and variance. In particular, last class, we look at the mean, median, mode. And the three things would depends on what kind of data you have, right? If mode would apply to nominal, right? Median will apply to ordinal data and numerical data. And the mean only makes sense when you talk about numerical data. Okay, so that would be the first thing we talk, right? And we mentioned that the three numbers, mean, median, mode, are the central tendency, right? And how to calculate the formula, right? Mean is just adding all up divided by total number of them. Median is exactly the middle guy, and mode is the most frequent guy, right? So basically, mean is centered by distance, median is centered by location, and mode is centered in terms of frequency. Okay. So the next is about dispersion. To remind you that why we need to have these type of numbers, right? It's because the central tendency is a number, but we don't know how good they are, right? We don't know how spread the data is. It's look at how good is our mean and median and mode. Looks like a lot of echo. So that is the key. And there are many ways to talk about this dispersion, right? And then you look at the let's see if it works. Okay. And there are at least 5 different ways to describe it. And the most common one, as you will notice, is the variance and its square root form, SD, right? And SD standard deviation will be the one that we use in the second half of the class very often. And this later you will see this is just we scale the version of the SD. Okay, basically it's SD, right? And these two are kind of raw measure, right? Based on the data, right? So just to recap, range is just the biggest number minus the smallest, right? And it tells you how distant between them. And of course, this is easily affected by outliers, right? And of course, I probably not drawback, but also a feature, right, as well. But because but sometimes you don't want this to happen because your data may not be nicely connected and the outlier simply is error, right? If someone typed the thing, they got error. But if the data is clean, this range will be accurate because you actually want to see what the outliers. Okay. And the example I've seen is that 5 number, 1 up to 5, and then the range is 4. But when you have 1, 2, 3, 4, 50, the range is 49 because the biggest minus smallest. And if you have 500, then will be 499. So it's very sensitive to what we have, right? Even though nothing changes except the largest number there. Of course, this would introduce us another more robust measure we call the interquartile range. Last time we will quickly go over that, but let's go to this again in a more robust manner. So first we have to tell you what is quartile first, because that is the basis for that. So quartile is actually related to what we call percentile. You sometimes learn, right? Percentile is percent is cut into 100 pieces, right? If a data, we have 100 data point, right? The first one is the first percentile, the last one 100 percentile. What's going on? Maybe with this is helpful. So quartile, instead of taking 100, you divide data into 4 different parts. That means quart. Tiles mean the square, right? 4 squares or 4 rectangles. And if you learn math, right? If you want to cut things into 4 equal sections, you need 3 different cuts, right? Because 1 cut will divide into 2. So easiest to think about the middle cut should become from median. Median is exactly middle guy. So that's why the median, also known as Q2, if you later want to Excel, Q2 will be the median. And if you loosely thinking, once you do the cut, you cut the data into 2 halves. And the first half would be the quartile 1, and the second cut will give you the third quartile. So the interquartile range is measuring the distance between the Q1 and Q3. So that would be the idea, right? Because if the data is spread out, the quartile is also spread out as well. So that's, we define the IQR will be the difference between the 2 quartiles. Okay. So that being said, this seems to be very simple definition, right? Because median, the formula is very simple. Right? You can imagine that then we just apply median to the first half of data and median the second half data, that we're done. Right? Supposed to be like this. Yeah, this is one way. The problem is a little bit like when you took the median, right? Do you take out the data from the Q2 or not? Right? The data there, the median data. Do you consider median in the first part of the data or not? So there is a complication there. Okay. And that creates a lot of way to calculate median, turn out to be. Okay. So, but nevertheless, let's see this symbolic representation of the IQR. So the range is the largest minus smallest. IQR is the quartile 3 minus quartile 1. So let's define some way to do quartile. So I will do the first method 1, method 2 first, and then tell you method 3. So why I do such a complicated way? Because method 1 and method 2 are introduced in high schools. I think I forgot which one is from UK, which one is from US. So usually there are 2 different ways in the high school system. So these are, you must have learned one of the way. Okay, one of them. And 3 will be the one that used in Excel. So that's why I have to tell you how you get the number in Excel. Okay, but of course I don't want to make your life too difficult, so I put it in technical. So just listen to it and can forget about it. But at least you know what's going on in Excel, because when you look at Excel, you calculate quartile is different from what you learn in the high school. Then you will just puzzle what's going on. I'll tell you how to get that one. But let's see, what do we do? Method 1 is use the median to cut the data in 2 halves, and the median is included in 2 halves. So you cut it, the median is still there. But method 2 is if the median should not be included. Okay, but let me show you the example. To example, then illustrate is very simple. First case, median include, second is not. So this case is very simple. 1, 2, 3, 4, 5. Okay. The median is by itself is 3, the middle guy, right? The third guy. Okay. And first half is you include the median into the calculation. So it's 1, 2, 3 is the first half. Free data, middle is 2. The Q1 is 2. Second half, 3, 2, 4, 3, 4, 5. The middle guy is 4. So Q3 is 4. The IQR is 4 minus 2. So this is the calculation where median is included. So second case, median is excluded. So if we have 1, 2, 3, median is 3. Median is not counted, take 1, 2. It's the first half. And you have two number, the median is just average, right? Because 1.5. If for this case, the second half is 4, 5 because median is not included. The midpoint is 4.5. So that's why the IQR is 4.5 minus 1.5. So it depends on how you do the calculation, the IQR is different. So it's really, it can differ a lot. Okay. And next example. But in this example, we have even number of observations. It turned out that they're the same. But these two methods doesn't make a difference. So if you look at this, 1, 2, 3, 4, 5, 6. Okay. The median is the average between the third and the fourth, right? Because the middle guy is the third observation and the fourth observation. So the median is 3.5. And because median is 3.5 exactly on the data, no matter what you think about method 1, method 2, same. Because the first half is always 1, 2, 3. The second half is 4, 5, 6. So the median of the first half is 2. The median of the second half is 5. So the IQR is always 3 minus 2 is 3, regardless of method 1, method 2, right? Method 1, method 2 is just whether median include or not. So no matter you are from UK or from US, right, the same result, right? If you have even number, right? But you have odd number, then you have different result. Okay. So if you use Python or R, actually this is actually there are two ways. There's two ways there you can find, because you look at them, they will give you for interquartile range or quantile, actually there are at least 7 ways to do it. 7, 9 ways to do it. These are 2 of them. I want to show you is one at Excel also have 2 ways. I show you one of them. So how do we calculate what you're doing here? Okay. This actually is very intuitive. That's why I like this one. So let me use an example before going into this formula, because I think you understand this and it's not that difficult. The idea is based on interpolation. So interpolation. The main idea is following. So because remember what we want, the first quartile and the third quartile is a quarter of data, right? And this is the third quarter of data, right? So how do we visualize that? Is actually we use the idea of the formula, okay? Is actually asking you what is exactly this number, okay? So maybe this number give us, say, 4.75, say, okay, 4.75, okay? Then what we're going to do is look at the fourth data and the fifth data. Okay, 4.75 means take the fourth data, take the fourth data and the fifth data. 4.75 means that you take a distance between them. Take the 75% of that, add to the fourth item, and that's it. So that's the formula. You take the integer, that's fourth function, is 4.75. You take the fourth data, and for the fifth data minus fourth data, you take 75% of them, and that's the formula. Let me repeat. So suppose you calculate this number, m plus 1 over 4, right? It's like 4.75. Okay, so suppose the easier case is 4.5. Okay, 4.5. Then easier to think is just like take the fourth observation and the fifth observation, take the middle, right? That's what we do in the median average, right? It's always 0.5. But what is 0.5 here? Is from the smaller number to big number, you run halfway, right? So if you get the number is 4.75, that means that you go from the fourth and the fifth, go 75% of the distance. So that's the linear interpolation. But anyway, seems to be a little bit very abstract. Give the example, then you will see it's very trivial. Okay? It's very trivial. So look at this question. We have 5 observations. 5. N is 5. N plus 1 is 6. Okay? Remember, the first quartile is n plus 1 over 4, right? So 6 over 4 is 1.5, right? So 1.5 is halfway between 1 and 2. How do you do that? Then you take the first observation plus halfway between 1 and 2 will be our Q1. Okay. So you can see the integer, look at 1.5, so you get 1 there. And then the remaining alpha is the remaining thing, it's 0.5. Okay. So that's what we get. The first observation plus halfway between 1 and 2. So that's what you get. That you get the Q1 is 1.5. Let me get Q3. Same is a third quarter of n plus 1. Right? N is 5. N plus 1 is 6. And because remember Q3 is a third quarter of n plus 1. So give you the number of 4.5. Okay? 4.5 that we start from the fourth observation. That's called the floor function. What's left is 0.5. So we start from the fourth observation. Halfway between fifth and the fourth will be our Q3. It's the difference. So don't worry, it's not included in the exam. So just maybe an assignment, but not an exam. Don't worry. So, but just have fun for you to see, because this is Excel output you get. So I have to explain to you why you get this answer. So now give you an example. You have 1, 2, 3, 4, 5, 6. N is 6. N plus 1 is 7. If you get to Q1 is a quarter of that n plus 1, right? So it's a quarter of 7. So it's 0.25 times 7, which is 1.75. 1.75. So what you do is you get the first observation x1 and a third quarter or 7.75 of the distance between 1 and 2. So that's what we get. 1.75 between 1 and 2. Okay, 1.75. Okay. And for Q3, the same idea, because we have 6 observation plus 1 times Q3 is 0.75. Right? The third quarter of that give you 5.25. Okay, 5.25. How do you do? You look at the fifth observation. You get a quarter between fifth and the sixth, because 0.25. Okay, 0.25 between 5 and 6. So give you 5.25 to the difference. So this. So don't worry, because in reality you have Excel. Excel just give the answer, they give you the result. So I'm not too worried about your calculation, but tell you that how you can get it. Of course, this is general practice. You shouldn't trust your software. You should know what's going on, right? At least you know what's going on, because your boss will ask you which quartile you're using, right? Because there are many ways. At least you know, okay, this is the way I'm using. I mean, whether you understand is an issue, but at least you know what you're doing. Okay, not super important, but just to get some idea that you know what you're doing when you plug in your formula there and get the result. Because now it's so convenient, right? You can use ask AI or ask software what's IQ of the data, but you don't know what is outputting, right? At least you know, right? I hope it's clear. So this is a graph that usually you would do to illustrate your data, and it's a box plot. You can do it in Excel or Python is very quickly. So I have 2 examples. Remember the data 1, 2, 3, 4, 5 and 1, 2, 3, 4, 5, 6, right? And you can look at the median is the middle box, and this is the maximum and the minimum, right? Sometimes maximum will be called Q5 and the minimum will call Q4, and this is Q0. But anyway, the distance between this is the range. The distance between this is interquartile range, and this median. So this box plot is very useful when you try to present your data to other people. Okay. Now I hope it's clear that how you calculate IQR and range. And usually it's good for presenting the data to your boss, right? Besides variance, because this is very convenient, right? Because variance is a number, you can't easily see things, but this is very obvious. So that's why we talk about IQR, I think, because when you compare this, right? This IQR is larger than this one. The range is also very obvious from this graph. So it's very good to talk about this, right? Because it's more visual, and also you can see the median as well. So now we come to a more refined measure. It's called variance because this is the thing that so often used in the second half of the semester. So you have to master it. Okay. So variance is not something too complicated by construction. Variance is just asking how difference from each observation from the mean. So it's a mean-based measure. So variance makes sense only the mean is making sense. Okay. So from now on, we focus on numerical data. Okay. So each observation take the difference from the mean. Okay. And this will measure how things are different from the mean, right? Because this is spread out. And what we do is we square each observation and over n, right? It means that, remember, you add every observation over n is average, right? So this is actually a mean, right? Mean is what? Adding everything up over n, right? This is the average square distance from mean, right? It's mean from the distance from mean, right? We want to do that in that way. So why? First, the question is, why we take square? All right? There's no point to take square, right? Why we have to multiply yourself? Why take square? I mean, this is something you learn in the high school, so tell me why. It's more fun, right? Otherwise, I keep talking, that's very boring. Yes? So if you don't take square, then it'll be 0. Always 0, because that's what I mean, right? Means exactly in the middle, where left and right. If no square, it's 0, because you remember the slide a little bit earlier. That's how the definition of mean. 0. You think square, this is 0, nothing to calculate. Okay? And square is one way to avoid cancel negative positive, so you're getting square. So that's one way, one explanation. But obviously, one classical counter argument to this is square is not only way to do it. Why don't take it to the fourth? Yes, why don't take it to more? Or why have to take what's going on this guy? Maybe yeah, okay. So why would take square? Okay. In fact, if you take fourth power, is related to the later today we say kurtosis. If you take to the power 3, actually it's called skewness. So related, very highly related to that. And 3 and 4 and actually higher order have some meaning as well. But we call second is square. But I mean, the natural thing is why we have to take square. Why don't we take absolute value, right? Absolute value, just no matter you take negative, positive, we get back to the positive, right? And actually, there's also a measure called that. It's called absolute mean deviation. It's called MAD, MAD, right? And probably the question is why we do square instead of absolute value. The reason is if you learn calculus, square have a nice smooth function, and if it is a absolute value is a kink in the 0 point, then make all the math doesn't work very well. So square have a very nice property in the math, so that's why we keep the math. But of course, there's some benefit of having a square is that if you are very further away, right? Because square is a convex function, it's like the further you go up, it's more steep. Which means that if you very far away, you square, it will become very large. So that means that you punish things that are very far away. That is the reason why it's good for variance, right? Because you want to measure how things are away. So that's why we have square. Okay? Is that clear? So why we have square? I think it's good to know. Now, if you look at Excel or many things, then you will notice when you kind of type variance, they will call variance.p and variance.s. You should try Excel later. We'll try. If not today, will be next week. You will have two versions, what we call population variance and sample variance. And why we have two things? Do you know why we have two things? Because I think it's good to ask. Because why we have two things? Why two things? Because variance, just variance, right? Why we have population variance and sample variance? Do you know why? Anyone have any idea why? Any idea? Yeah. Mm-hmm. So when we use population, when we use sample? Do you know? Okay. So for the sample, if you learn, many often you see this formula over n minus 1. If the population is this one. Okay. So why you have two different, why you divide n, why to n minus 1? Do you know the reason? Do they talk you about that? So don't worry, you will learn exactly why in the topic 6. But I will give you the answer now. But you will understand why in detail. But I will tell you why. So variance is always defined in this formula. Always. Okay? But if you try to collect data, okay, and use the data set to calculate the variance, to guess what's going on, you have to use this formula. So let me this is very subtle. Let me repeat what I'm saying. So if I have all the information in Hong Kong, suppose I want to calculate the variance of income of everyone in Hong Kong. If I am government, I have all the information. To calculate variance, I always use this one. That's the only formula you do. Okay. But if you collect data, okay, and suppose you get 10,000 people, you calculate the mean, you calculate the variance. And if you want to what you calculate, that variance is a good guess on what actual the population variance is. Then you have to use this one. Okay, that's what I say. One of the reason why the nice one, because this guy X bar is also get from the data. So that's the reason why later you see if you want to guess the population variance nicely, then you have to use n minus 1. Okay, so because in some sense it's because we always only get sample most of the time. So when you want to guess what's going on, it's this one. So if you use data to calculate, your answer is this one. But remember, you're guessing this guy. Okay? You're always guessing this guy. This is our objective. But in order to get the objective, you have to use this formula to get it. Okay? So my metaphor always is like this. I don't know whether you like it or not. Anyone play basketball, right? If you're very good, well, let me draw a picture. So I'm not a good sport, but you can tell me this is the right metaphor or not. So it's a basketball. There's a board there, right? So unless you are Stephen Curry, right? So you try to throw the ball, right? If you're good, you can aim for this guy. But usually not that good, then you aim for this space and bounce back, right? So that's same as estimation. Very often you really can't estimate, go to that directly. You have to go a detour. So that's same as all this thing, okay? Actually, you could ask, is the mean you calculate have to do the same? No. Calculate mean can be do directly. You don't need to adjust n-1, luckily. We'll show you why at the 5th or 4th topic, I think the 6th, half the class, I think October. We'll tell you why, okay? At least the mean, you get the data, the mean, you don't need to adjust, okay? But the variance, you need to adjust. Variance, very strange. I mean, the first time whenever who learns statistics always puzzled by this one. At least puzzle me for a long while. Why you have to adjust. But the idea is only if you do this, you get the correct estimate, the better one. Okay. So that is why this is called the adjustment. So the sample cutoff. So that to recap, you always want to measure this guy in the population, say in Hong Kong, you want to estimate the variance of income of everyone. If you have all the data, you just divide it by n. Okay. But if you only want to get some data there, that's what I call the sample. You get some data there and you want to guess what's going on in the whole population, then you have to use this one. I hope that will be clear. Okay. Now just give you some quick example to calculate that. So suppose the data 1, 2, 3, 4, 5, the mean is 3, so give you the second column. And you subtract every data from the mean, give you the third column. You square each number, give you the last column. Population variance, adding up everything in the last column, divided by n, which is 5. The sample one is 5 minus 1, 2.5. Okay? Okay, so when to use what is, if this 1, 2, 3, 4, 5 is the only data you care, right? You don't care anything else. If you only want to draw conclusion of this, 2 is the answer, right? You don't want it to be the population. It's something you care, right? But if you think that this is only the data that you want to guess what's going on in the bigger picture, you need to take the n-1. So that's the difference. Is that clear? If you want the variance, this is the only thing you want to study. And you don't want to extend your knowledge, just population. That's it. No more. But if this is something that you are trying to, it's a sample, it's a subset of individual that you want to study the whole thing, then you take the n-1. Okay. So that's difference. And the next is sorry, standard deviation. This is just taking the square root of the variance. Okay, probably can tell me why we want to take square root, right? Why we do that? Of course, the answer is on the slide, but you can tell me why. Can you tell me why? Why we take square root? No idea. You know why we take a square root? You know why we take a square root for the variance? Any clue? To get standard deviation. Why? The answer is already on the slide. The square root is because when you square things, every measurement unit will be square, right? If you have measuring length, right? Variance is just areas. Cm, say suppose length is cm, you get the cm square, right? So you don't want that to happen. So you take a square root and everything go back normally, right? So but then you take a square root, the whole thing. So how they're related is a little bit different, right? But that would be the idea, right? So the same idea, you have the same thing happen. Okay. Is that okay for the standard deviation? That's how you compare things. Okay. The next is something not very difficult to see. It's called the coefficient of variation, which you divide the standard deviation over the mean, okay? And very often you multiply by 100, okay? And you ask, what are we doing here? what are we doing here is to look at the spread measure normalized by, we call normalized, we scaled by the mean, okay? And you ask why you need to be normalized by the mean. The reason you normalize is because you want to compare, as I said at the beginning, you want to compare data set. Say, for example, I want to compare variance between midterm, we don't have midterm, so don't worry about it, and final exam, right? Midterm maybe have full mark of 50. Final, we have the full mark of 100, okay? So, but they are different things. So how can you compare variance, right? The final must usually have more variance than midterm, right? Because larger number, right? Larger range. Okay? So in order to compare midterm and final, you want to see people will have more fluctuation in the final than midterm, right? Then you use this CV, right? You normalize, you divide it by the mean and multiply 100. Then you can easily compare different group. Okay, so that's how you do the calculation. Okay, it's only useful when you compare different things, right? That is more useful. Okay, so these are the very standard. So that's why the name, as it's called, coefficient variation. Right? It's variation coefficient. Right? So that is very clear. So let me go to example to show you the calculation. Right? Remember the case 1, 2, 3, or 5. We calculate means 3, and the variance 2, and the SD will the sample variance is 2.5. Right? That means that you take a square root of 2 and 2.5, give you the sample standard and the population standard deviation, right? Do you always note that the sample version is always larger? Okay, and it makes sense because you calculate sample, right? It means that actually there's some randomization of what sample you got. So that's why the variance calculation should be larger. So that's the idea behind. And you divide that by the mean, then you can see this how to calculate the CV. Okay. So this is all the simple calculation. Okay. Okay. Now, with that, I think we can go to much more fun because this is nothing. I don't think you ever studied this in your high school. So we go to a more interesting thing. It's called kurtosis and skewness. And that would be very useful when you report it to your boss. These are numbers that you want to know to check. So first one is skewness. The formula looks crazy. That's like what's the monster goes on here. Okay. But don't be scared by the monster. Okay. Actually, it's very simple. Okay. The skewness, look at the numerator. The numerator is not very crazy because the numerator is, if you forget about 3, become 2. That's variance. Okay. But now with 3. And below what's going on, it's just standard deviation raised to the power 3. Okay. And why we do that? Okay. First, this thing is unitless, right? Because this raised to the power 3, this raised to the power 3. So it doesn't affect by the unit. Okay. And why raised to the power 3? As you suggest, negative, positive, right? You raise to the power 3, things will not cancel out, right? Because larger number get very large. Smaller number gets not so small, right? When they're close to the mean, they take power 3 is very small, so it doesn't really. But if you're far away from that, raised to the power 3 will be very large, right? So if the data is not symmetric about the mean, if not symmetric about mean, let's try to do that. Hi, let's try this one. If the data is not symmetric about mean, right? Something is like more skewed, then raised to the power 3 will be very large, it will become positive, right? If the data is skewed to the left-hand side, then it will be very negative. Okay. So that means that if, as we said here, the skew is 0, it's perfectly symmetric, but usually you don't see that. But when skew is positive, okay, then it's right skew, right? Because a lot of data there. And the left is left skew, okay? But that is the idea, okay? And okay, so this is the definition of skew, okay? Looks very now after explaining, it's not that crazy, all right? It's not too crazy to have this formula. Oh, this mic is too low. I don't know how to do it. Can I sit? Because I really can't. I can't really bend my. Sorry for sitting. Doesn't seem to be good. So, but this formula is not actually used in practice. The formula used in practice in also in Excel, you have skill this and skill dot P. So by construction, you use the skill, they give you this crazy formula. If you dot skill dot P, they give you this formula, okay? And you ask why this formula. Again, I said, if you have a data, you want to guess what the skill is in the data, use this crazy formula, okay? And don't worry, this crazy formula is given by Excel. So I try to give you this. It's because this is given by Excel, right? So if you want to understand what Excel gives you, this is the formula, okay? And you can see it's not that crazy here because this guy is what we expect to have, right? Because I just before is dividing by sigma square, right? I divide by the sample standard deviation, but I just adjust by some n, okay? And when n is large, this thing doesn't really matter anyway, right? So when n is large, don't really worry too much about this. The two weights is very similar, okay? But mathematicians are very picky, right? So we have tried to make sure everything is right, okay? But that being said, I mean, doesn't really matter that much. Okay? So just give you some idea on the data. I really hate it. I so see stand sitting there. So the calculation is very simple, right? Just calculate mean and subtract. Instead of square, you take to the power for third power, right? And then to calculate the sample, you make sure you divide it by n minus 1, right? And take a square root. And the population version is just very simple because this is symmetric, so expect is 0. Even the population one, just sample one is also 0 as well. Okay, you can go and check whether this number makes sense to you because you apply the data. But don't worry, you will do assignment, which asks you to do same thing but different data. So you would apply once again. And if you want to visualize what is skewness, example like this: if the perfect case, a bell curve, skew 0 means they're symmetric. In this case, mean, median, mode are the same, right? This nicest form, okay? And if the data is instead is not 1, 2, 3, 4, 5, it's 1, 2, 3, 10, you can imagine that this is positively skewed, right? Because the mean is 4, right? And then you have a 10 there, 10 is way larger than that. So as expect, the skew you calculate is more than 1, right? And this skew doesn't really represent, but this one is more much bigger, reflecting what we want. Okay? And don't worry, these are things you just put in Excel, just calculate. Right? So it's nothing very special calculation, but you can check Excel why that right happening. Okay, but I'm not going to go into every single calculation there. But if you want, you can ask me. But you will do when you do assignment, you know there. Okay, we will be working on creating this table and work it out. So this example looks like this. Okay, 10 there. In this case, the mean is bigger than median. Okay, in general. Okay, and in other case, skew negative looks like this one. Okay, so I'm not going to do further, but rather I want to tell you why we need to care about skewness. Okay, and if you learn finance investment class, I think next year is 3,000 class, and you look at finance, most of the time you look at is they only classical finance. They only look at two things: mean and variance. Mean is expected return, variance risk, right? And the classical finance theory would tell you risk-return trade-off, right? If in the market, if you want more return, you have to take more risk. And that's it, no more, right? That's the end of story, right? But these days, people discover that not just that, not mean and variance is not sufficient. You need skewness. Actually, skewness is part of the pricing equation, okay? And skewness, okay? People would value stock that have positive skew, right? Negative skew means go negative, but stock is limited by, the worst case is you throw away the stock, right? So doesn't really, no one care about negative, but positive skewness, you pay a lot. What are those? Positive skewness stock are just crazy stock, right? The crazy stock that actually would have a very growth high potential, right? So people are actually willing to pay a lot for these skew stocks, right? So that's why people invest in, it's like, that's like gambling. It's kind of, right? People have value for gamble. So if a pop skew, that means that you have a lot, right? So that means that if you look at the pricing equation, skewness actually carry premium, which means that if you do the pricing formula, you have to do it, right? Why people buy cryptocurrency or people buy NFT, right? NFT basically useless, but we may have a large skewness, right? May have a very high value. You don't know. And people study the financial crisis 20 years ago, right? Almost 20 years ago. It's because of the people, if you know the story, will be people, they do the option pricing or future pricing are based on normal distribution, if you know what's going on, but it's based on mean and variance. And they forget about skewness. And when that, but this kind of the black swan effect actually happened. The skewness captured those kind of ideas. Okay? And that's why people buy lottery, right? Why people go to Macau, right? You know, if you stay in the casino long enough, you lose all the money no matter what, right? Because it's unfair bet, unfair gambling. We'll talk about next topic. But people nevertheless go there. Why? Because you may earn a lot, right? On average, you're losing, but a chance that you can win a lot, right? So that's why the skewness is something that people would value a lot, okay? And what happened when the data is skewed? Okay, often data is skewed. How do you handle that? For example, stock price. Stock price is skewed, right? Because always positive. It can't be negative, right? So how do you do that? So that's why in finance, you don't talk about price. You talk about return. When you model the thing, return, you can go up or go down. Can be zero, can be negative, and positive. So that's why we don't talk about price, the model price. We would model the percentage. And similarly, when you try to look at things, you look at the ratios, financial ratios, income growth, income growth. Sorry, some typo there, but I think it's clear what's going on. Okay. So not going to tell you how to do that. Many other ways to transform. Okay. There's some way to transform with left skew and right skew, take a square root and also some transformation. Okay. So before the break, I want to talk about this formula before the break, because the formula is very simple. This is just change 3 to 4. It's called kurtosis. Very simple. There's nothing new there, right? There's nothing surprise, right? Because this kurtosis is 4, right? Just to remind you what is 3, right? So there's nothing new there. It's just 3 to 4. Okay. And why is 4? Because 1 to 4 means that things far away from the mean versus the power 4 would be super large, right? The power of power is very powerful, right? So that means that I don't care if way below or way above, because 4th time everything is positive. Okay. And before the end of the break, usually this is numbers then how can you do a comparison? And the usual thing we do is compare what we call the bell curve. I hope everyone knows the bell curve. We will talk about that later. It's something called normal distribution. And the bell curve by construction is have 3 kurtosis. So you always compare to 3. If the kurtosis is more than 3, it's fat. Less than 3, it's called thin. That's it. Okay? And this is what I said, but I guess we should have a break, as I promised. I will put the U replies on. Take a break. So you're welcome to give me a feedback during the break. We will resume at 2:38. Honestly, we won't. Anyway, let's see. We have 16 people filling in. So you have a, so it's good if you try to fill in, but it's anonymous. I'm not taking attendance based on that. At least it's not before the actual period, so no point to take attendance anyway. Okay. Who switched off my screen? Okay. So I have to do it in this way. So let's see the result. Let me end it. And the PowerPoint is nice and clear. Thank you. I hope this is clear enough. Yeah, I can give exercise to do that. But basically, I would suggest the easiest thing to do is to go to the example. You cover the answer, you do it again. That will be fine. That's sufficient enough, because if you can recreate the example I give, it's done. Because as I said, these days things are easier. So you expect my exam or assignment will be very similar to the example I give. Okay, even by that, I mean, not every people get good score from the exam, so that will be fine. Thank you, but I don't think that's far from truth. But anyway, thank you for that. But I don't know, it's not anonymous, so saying that will not help your grade. I'm sorry about that. You mean, do you want to form a group from other section? I don't have anything to say, because it's okay. As long as you submit the homework, you don't complain your group mate, then it's fine. I don't have restriction on that. Of course, it has to be my section, right? You cannot collaborate with other people in that section. It's not going to work, but that's fine. Good to have lesson today. Yeah. Oh, you don't have to. It's open book. Open book exam. So bring whatever you bring to the exam theater. Do whatever you like. Just no iPad. Only thing I don't allow because of cheating concern. But otherwise, I don't have anything to say. Okay. Next. The key point, yes, the population variance, sample variance are different. Okay. When if you are looking at census data, the population won't be done. But if you are collecting data from somewhere else and then you use that data to guess what's going on, then will be the one. Okay. Yeah, the box plot is very important. Okay. Now you know the meaning of square, so very good. So you can explain. So you should be able to explain every single formula you see intuitively, not just the math, but what is the thing behind. I think it's very important. Yes, that's right. I hope you learned that. That is very important because that's why we have open book, because I don't want to remember the formula, but rather you understand why we have this and how to use them. That's very important. Yeah, skewness and kurtosis is the same. Yes, that's great. I think you learned it. So very good that you like my speed, although there's one person who think I'm a little bit too fast. So let's see if I can improve further. And on average, 3.4, so it's not that bad. Okay, it's okay. The microphone is bad. I know. I'm so sorry about that. It's not my microphone. It's the microphone have to be from every lecture room have the microphone. It's not my microphone. So because this is paired with this room. Even though I want to have my own, it doesn't work. I'm sorry about that. So yeah, open Sam dinner. Yeah, good. I hope you are happy, enjoy the dinner, have fun. And I want to buy a better mic, as I said, can't really do it. And yeah, hopefully you learned it. Yes. Okay, that's good. So let's go back to here, kurtosis. Because this monitor is dying, so I have to go to here. So kurtosis, as I said, is raised to the power 4. Okay, basically asking how much different from the mean. If you far away, raised to the power 4 would be super big. Okay, so the benchmark is looking at 3. Okay, if you're more than 3 or less than 3 will be the concern. Okay, 3 is the bell curve standard. More than 3 means -3 is positive. It's a fat, it's thin, and you happen many often you see some Greek letter, Roman letter, mesocratic, lithocratic, and platocratic, but it's not required for our class. I just put there because of you may see them somewhere else. Okay. So, okay, monster comes in. Don't worry about that. You are not going to do it anyway, but just telling you that Excel output is not the one we saw. Excel output is this guy. Okay. Of course, Excel, don't worry about that. Is the calculator give you this one. And you may ask why this guy is way beyond our cost to explain this. But the same idea. Okay. If you want to estimate from the data, this is what you use. If you have the whole set of data, use the population one. If you only have what you have is just a subset of the thing you want to study, use this guy. Okay. And this guy, if you use Excel, directly give you is KURT, Kurt, and that's it. Okay, we'll talk about Excel very soon. Okay, but that is the formula that we use. Okay, so this is the example you do, and of course you go home, try to cover this, and do it again. Okay, this is the old style of learning math. That's what people told me when in old days you don't have much material, so we just use the blank A4 paper to block it and see if we can recreate that. That's the easiest way to learn because you know the answer already. Okay? So I recommend you to do the same because I think you guys are very busy. So I don't think I want to invent more questions for you. But for sure, if you really want, you can look at the textbook. The textbook has, I think, odd number question or even number question is there. Or you can go to the central library that manages that textbook. You can just pick up whatever one, just do it. Okay. Or you can download my textbook, which is freely available online. We have question and answer over there. So many ways to do it. Same. This is you can see when you change to 1, 2, 3, 4, 15, the total is much larger, right? It's more than 3. Okay. So that is, and that's why you want to use sample one. The population one, excess kurtosis is not very large. It's fairly more than 3, But when you calculate the example one, excess kurtosis is way bigger than, right? This is bigger than 0. So that is a reason why you want to focus on that one. So now I guess the formula is not very important, but rather why we care about that, right? And as I said, financial crisis is they forget about the extreme risk, right? Because the kurtosis is the chain reaction between the whole systematic risk. And also, some of you know I am actuarial science major in the 10 years ago. The insurance thing, we care, right? Because when flooding happen, it affect everyone there badly. So every house have to pay. So for insurance company, they do care about this kurtosis a lot. So that's all the calculation there. And these days, people care about fairness, income inequality. How to measure that? It's kurtosis. Okay. So if you want to come, you can say why this data is more unequal to over the others. Kurtosis is the key, right? And kurtosis also, kurtosis in business is application is if you're marketing, looking at the market data, right? And look at the income or look at how people want to spend. Kurtosis will tell you that whether you need a single version of product or multi-version product, right? Do you need so many versions of iPhones, right? I think now they have the rumor is that the iPhone Ultra is fully transparent, right? I don't know whether it's true or not, but the question is whether you need a very different type of product, right? Can be depend on whether existent or very rich and very poor people, right? Okay, so now we end all three types of statistics, right? You give data, you want to summarize. The first one is like central tendency, mean, median, mode. Also, the second type is called dispersion. You have range, interquartile range, variance, standard deviation, coefficient variation. And third type is the shape. We just learned kurtosis and skewness, right? Which capture whether data is symmetric or the data has a fat tail, right? Or not. So this is done, okay? Now here comes something that probably also learn as well. It's called correlation or covariance. It's how you are trying to not just one single measure. You care about, you observe two things from the same individual, right? So you want to see how they're related. For example, right? X may be GPA, right, from student. Y may be how much time he spent on studying, right? You want to study whether people spend more time on study, lead to more GPA, right? It's whether the talent matter or you study more is going to be helpful, right? So that's something you care, or you want to see which is most important for you now is with education lead to higher income, right? Now you are in second year or third year. The question is once you graduate, whether you want to take a master degree or you go to the job market, right? Or even PhD degree as well, right? So then you want to see whether education actually help, right? So the first thing is to look at how they're related. And the measure of them is called covariance and correlation coefficient. Not surprisingly, covariance is related to variance formula, very similar. And correlation coefficient is coefficient means you divide by something. Okay? So very quickly. So covariance, the formula looks crazy. Okay, don't worry. If you forget about the y, you take a square, this is variance, right? And you probably want to know what is this formula, right? Because you can always bring the formula sheet to the exam, right? So you ask the question why we need this formula and what's capturing, right? But of course, do note that we have a population and sample and minus one, the same idea. I'm not going to repeat, but rather I focus on the idea of this formula. Okay. So look at the numerator, which is xi minus x bar and y minus y bar. What is doing? So you can see this thing will be positive if both are positive or both are negative, right? Both are positive means that both X and Y are above the mean at the same time or below the mean at the same time, right? Their negative is one of them is positive, one of them negative, right? So that means the following. Let's see the graph to show you. So if this is the data, this is the mean. X, the mean means look at all the distance. Here, the middle, the distance between them, the left and the right same. And Y is here because the distance between up and the down are the same. Okay, so that is, remember what the mean is. And when you have positive covariance, which means that the data are either in this first quadrant or on the third quadrant, right? On the northeast or the southwest, they're positive. And these are negative, okay? Positive means data are all here or mainly here rather than here, right? Because at every observation, you add the product, right? So that is the idea. Okay? If positive means all data are here. Negative, the data are all here. Okay? So that is what the covariance capturing, right? If this negative, this negative, right? So that is the idea. It's capturing whether they move above the mean of X and Y at the same time, or they're below the mean at the same time, right? If above the mean at the same time, then yes. If not the same time, negative. So whether they're positive slope and negative slope. That is the simple idea. Nothing more than that. Okay, very simple. I hope it's very clear. So that means that if you want to study two variable, right, you want to see whether they're positive related and negative related, this is the way, right? So you want to see that your education and income, the first thing to do is to calculate this, right? Look at everyone, you subtract the income over the average income, subtract the GPA from the average GPA, multiply them, add everyone's up, divide by n, then you're done, right? So very simple, okay? And you have the population version and sample version as well, okay? This is the thing you see, right? Of course, life is not so perfect, but you may have some point here and there, but this will override the thing, right? This negative, positive. So that's how you get, okay? So, of course, you know positive, negative, but it's not easy to compare, right? So how to make our life easier? So usually we don't use covariance directly, okay? We'll use the transform version. It's called correlation coefficient. What is good there? Okay, you can see this formula is crazy, but anyway, forget about crazy formula. What it's going to do is the numerator will be the covariance. The denominator is the standard deviation of X and Y. Why do we do that? Okay, the thing is, once we do that, this measure is always between -1 and 1. Okay, that means that 1 is very strong, positively correlated. -1 is the worst case, negative correlated. Okay. And let me show you a graph, then you will see. Okay. And this is 1. A perfect line is 1. Perfect upward sloping line is 1. Okay. And lots of perfect line is positive. Okay. The more closer to the line is more closer to 1. Okay. This is positive. And this random, you can't draw upward sloping, you can draw down sloping, it's 0. Okay. And if you become downward sloping, then it's negative. If it is perfect line, -1. So we can basically tell you that how they're related. Okay. If the closer to 1, the stronger the thing. Closer to -1 is closer to negative strength. Right. So it's very simple measure. Okay. So that's why correlation is the way you can tell people how two things are related. Okay. And at the very last topic of our course, we talk about regression, is to make this statement even more mathematical, more useful. Okay, we don't have a model there, but just a measure. But if you want to have a pure regression, we simplify this into a line, and then we can do a lot of modeling prediction. Okay, because so far we don't do anything, but when we run regression, we reduce the data into a line. It's a lot of reduction in the complexity. Okay, but now we just don't do any modeling, just a measure. Okay, because remember, this is descriptive statistics. We don't produce new knowledge, right? When we run regression, we collect things and say this represents the world. Is we creating new knowledge. We don't create new thing here. What we get is from the data what we learn. Okay, there's no new thing created. Because when we draw a line, it's already creating things, right? Because the data, when you draw a line, suppose you have a line here, you're telling things doesn't exist in data. You're assuming something there. So it's creating new thing. For this, we don't create new stuff. Okay? And just to recall, the formula again, okay, is the covariance. If you divide by n, it's covariance, right? And the variance divided by n, right? And you do look at this, the correlation coefficient, perhaps not surprising. There's no sample version or population version. The reason is if you divide by n above, they cancel out. You divide by n minus 1, they all cancel out. So no matter you use the population one or the sample one, the same. Okay, so that I think that's why I read, right? If you divide by n minus 1 or n, the same thing. So that's for this interesting thing, right? There's no sample version, right? So the only thing don't have sample version is the mean and correlation coefficient, right? Because they cancel out. Okay. So this is the last example we're looking at. Okay. After that, we talk about Excel. Very happily. So now look at the data. We have X 1, 2, 3, 4, 5. Associate Y is 4, 7, 6, 4, 9. Okay. And then you calculate the mean, which is 3. This mean is 6, right? You subtract X to the mean 3, you get -2, and so on and so forth. And you subtract 6, you get this and so forth. You multiply these two columns, give you this result. If you square, you get this result. You square this, you get this result. Okay. And covariance is simply you add everything in this column, which is 7, right? Divided by 5 observation, right? If you divide by 4, is the sample covariance. Okay. And the correlation, right, will be just the covariance divided by the standard deviation or the square root of the variance, right? The variance is 10 because this thing add up divided by 5. Okay. And you do the same, you can check it out. Everything should be all right. So don't worry. Assignment 1, we kept you to doing that again. So you will be doing that. If you want to go home, have fun, you just A4 paper, block it, and see whether you can reproduce that. Okay? If you can reproduce that without too much trouble, then you're okay. Okay? So the first topic is over for the theory. So for the remaining 15 minutes, I want to talk about Excel. But just before that, we talk about some example, right? A lot of correlation apply. So what's finance, marketing, supply chain? I'm not going to read one by one because it's too tedious, right? And one thing I have to remind you that correlation is different from causality, okay? And X is related to Y, doesn't tell you X cause Y or Y cause X, or they both cause each other, or there may be some Z causing X and Y, okay? We don't really know. Then the question is, probably you ask is, how to express causality, right? This is the most important thing, right? We want to see whether you take the medicine cure your disease, right? It's not the other way around, right? Or maybe there's some natural factor, right? So you don't know which one is going to be true, right? So how did you do that? Unfortunately, it's not possible in undergrad. Okay. But the simplest thing, still you can say something. In science, is what we call control experiment. If you can control X, okay, if you control X, then you can correlation is causality. Okay, that is what we do in experiment. But if you can't control X, which often happen the case in business, okay, then you have problem. But at least in marketing or many case, you can control X, right? Suppose you change the price, right? And you can see the demand changes. Then you can say the price changes lead to demand changes. Or you are going to do some marketing campaign, which you control it, and you can see the effect. Then you can establish causality, right? Otherwise, if you are not the one who control it, you just observe things happening, you don't know. Okay, so that have to be very careful. But in our case, I think the example is like this, right? X is summer clothing, Z is Sunday weather ice cream sale, right? And they are all positively related, right? Then probably if you don't observe Z, right, you will see summer clothing is correlated with ice cream, right? More bikini is being sold with ice cream. So probably it's ridiculous, right? Probably you will want to do other way or other thing as well. But I guess it's beyond the scope to talk about those things. So if you want to look at that. But just minor recap here, right? Those people actually taking VO, right? Look at the mean and median, right? It's return and deviation and variance about riskiness of the stock, right? And positive skewness is also going to give you a good stock, right? And low kurtosis is also good because extremely risk is also gone. Okay, so these are the things that actually useful for the other class you might taking, because everyone have to take the investment class, I think, right? And probably this example, right, is you learn that in the investment class. I'm not going to talk about that anyway. And finally, I think this is so good to talk about good portfolio, right? Which we don't have time to talk about that, but if you have two stocks, right? And if the two stocks are negative correlated or zero correlation, actually it's good because the total variance is lower, right? Because one go up, one go down, right? The variance cancel out, right? The portfolio, right? Because if they always go in different direction, so they're more stable, then they all move at the same time, go down at the same time. So that's why the investment people try to look for investment opportunity that are negatively correlated with the standard stock market, right? So that's why they invest in gold, invest in Bitcoin, because they believe that they'll be unrelated to US stock market. Okay. But I don't want to talk about investment too much because it's not investment class anyway. So this, I know what's going on, but this has QR code to the video if you want to read it again. I think I do it during the COVID time. But anyway, doesn't really matter anyway. So Excel, I hope you install Excel in your lab, in your MacBook, your iPad, your phone also work. So also phone is also doable. So we start from scratch. Let's see if I can switch this guys on. Okay, that's fine. Okay, so let's me open Excel. So as I said, I assume zero knowledge, so I start from scratch. Okay, so Excel is the idea of spreadsheet. Okay, spreadsheet is bunch of cells, and each cell is characterized by column and row. Okay, and the first cell we have is A1, B1, A2, B2. And what we do is Excel is we have this formula box. We type the formula there and do all the calculation. Okay. I illustrate by showing you the most simple operation, arithmetic. I would do addition, subtraction, multiplication, division, and take the exponent. So let me do the addition. So you start from having equal sign. Okay. And 1 plus 1 equal to 2. Okay, that's the formula. And to further show you this is I will show you a particular thing, what we call function. If you don't do operation there, you can put a formula, and that's the power of Excel, is there's a built-in formula, built-in function that can do the calculation. Okay, so what we do is we do the formula. Oh no, what is formula? Formula text. Okay, and this will show you the formula. Okay, so that's how I would do it. Okay, then I will have 3 minus 1. Okay, and 2 times 2, and 4 minus 5. Okay, and here I want to illustrate a particular shortcut that is particularly useful. Is because this is all filled up and this not. So the shortcut is you go to the right corner, right bottom corner, it become a cross. Use your mouse, quickly double click, then done. Okay, so this is a very useful skills, at least for me. Okay, so that will keep the formula. Okay, so I hope you are able to do that. Okay, and the last one is raised to the power 2 to the power 3, like this. So that would be the idea behind the simple calculation. Okay. Now, once you have done, is that okay? Anybody have any question? No knowledge. You can do it on your iPhone, do it on your laptop or iPad. Everything should be working as well. Once we're done, let's go to the next page. Okay, this is what I have already. So I want to talk about square root exponent because they're all functions. Okay. So there are 2 ways to do it, right? You get equal, take a square root, because we take square root of a number 2, that will give you this answer. Let me do the formula test as well. So I have directly put a number there. Okay, and also I can do exponential to 2. Okay, will also give you the answer. Okay, so it's e to the power, which you will use it when we talk about next week. Okay, so this exponent e is just 2.7182. You will learn that it's a continuous compounding interest rate. Okay, also in our Poisson distribution later very soon. Okay? And here comes to some important function called count and sums. Count is just count how many of them, right? Sum is sum of them, right? So, and I'm not going to write that down here because it's very simple. And also the run down and run up, which is already we learned from the slides. So these are the thing. I think they're too trivial. I don't want to repeat that. Okay. I'm not going to do it on the slide. Instead, I want to spend time on talking about average because this is a mean thing. Okay, mean is going to give us the mean, as we know, right? So for Excel, if you want to calculate the mean, it's average. It's mean, right? So mean, no, it's average. Okay, and if you want to input the data, okay, you have to the curly bracket 1, 2, 3, 4, 5. Okay, close curly bracket like this. So the curly bracket is to tell the Excel these are all the data. Okay, So of course, sometimes you can omit the curly bracket. It still works, but it's not the formal way to write it. Okay, sometimes you have problem. Okay, but this is the correct way to do it. Okay, and of course, you may wonder if you do this, what is benefit of Excel, right? Because Excel is trying to display the data and the calculation at the same time. So that is differentiate Excel from Python. Because Python is separation of data and the code. But Excel is combine them together. Okay? So how do we combine them? So instead of giving a number there, you can give what we call cell reference. Okay? So suppose the data is 1, 2, 3, 4, 5. Suppose data is called here. 1, 2, 3, 4, 5. Right? So the data are populated over A7 up to E7. Right? So what we're going to do is to do the following. We have average. Okay. And we will tell the data is actually from A7 to E7. So it's A7 colon E7. Okay. Once we do that, you can see Excel very nicely. I already bracket out the data. Okay. So that's how you calculate average. Okay. And now, so now you understand how to do it. So now let me tell you the formulas that we used to learn, right? So the several formula there. This is some basic. Okay. Now we have some summary statistics. So we're going to tell you mean, variance, those kind of things, right? So we'll quickly, we still have 2 minutes, so let's quickly do it. 1, 2, 3, 4, 5. Okay. Mean will be just average of all this. Okay. And let me give you the formula test directly. And median will be just median of this. Maybe I change to 3. So what another good thing about Excel is you change the data, immediately change calculation. So I change to 3. And mode, the same. There's some complication there. Because Excel can only, the standard Excel function only output one thing. Okay. So if you want to export more, it will be an array function, which we don't want to cover that. So we just do the mode single and highlight this thing. Then you give you all we want, the mode. Okay. Is that clear? So we have mean, median, mode. So I know the time is strict, so I just tell you the last one, range. The rest I'll talk about the next one. So range is maximum minus minimum. Okay. So that means that I can exactly do the same. Max of my data minus mean of my data. Okay. So there's the formula there. Okay. I'll keep the IQR, standard deviation, kurtosis, all the thing in the next class. But more or less, of course, you can check the slide if you're interested in that, but I'll go through everything in next class. So this is what we have. So you can see Excel very quickly, you can do all the calculation without spending sweat of that. Okay. So I will see you next week. See you on Monday, I think, right? Monday class. Okay. I show Monday. I'll upload these slides, but upload the worksheet to the Blackboard. If you want to take a look, you can have fun. So that's okay. I'll see you next week.